Hi everyone, welcome to Practical Electronics. In this tutorial we're going to take a look at the design of a variable power supply. Let's take a look at some points on power supplies. Power supplies are a way to provide power for our circuits. Some can have a fixed output, while others allow for the output to be adjusted as needed. By designing your own, you are able to control the voltage and current supplied to your circuit. For electronics, our power supplies will always have a DC output, but please do note that a power supply can either take a DC input as its source or an AC input. This tutorial will show how to build a variable DC power supply with an AC input voltage. Please note that you do not need to make this power supply in order to power the projects that will be covered in this series. Always take care when working with live electricity. For this lesson, we're going to look at theory and do a recap on fundamentals. We're going to look at circuit components, the circuit layout, the build of the circuit, the results, as well as some observations. Let's recap on some theory. Alternating current is current that changes its direction periodically. Power comes out from our plugs in AC format. That's 230 volts AC at 50 Hz frequency. AC power is stepped down using transformers. The process of changing AC to DC is called rectification. Capacitors store and dissipate electric charge. Resistors resist the flow of current in a circuit. Current chooses the path of least resistance. Let's take a look at the design process. For this design, we'll have an input, a process, which is where our circuit design will take place, as well as our desired output. For the input, we're going to take a 230 volt AC input, and for the process, we're going to have a three-step process that we're going to follow for the design. This will be transformation, rectification, and regulation. For the output, we're going to have a fixed output of 5 volts and a variable output going up to 16 volts. These are the components we're going to use to make this power supply. The main components to take note of are the transformer, the full wedge rectifier, as well as the voltage regulator. Because the voltage regulator is the main component of making this variable power supply, let's have a look at the datasheet for the adjustable voltage regulator. As you can see, you can check out a few manufacturers. A datasheet will always show you how their components should be used in a design, and it will show you some defining parameters of the component as well. These parameters will show you the limits of the component. As you can see, even from a different manufacturer, you'll have some defining parameters for your limits, some performance statistics, as well as a common design to be used. So we will be following the design from this datasheet. Let's take a look at the circuit design. AC power will be brought in from a wall power plug. A transformer will be used to step down the voltage. A rectifier will be used to provide an adjustable output voltage. A variable resistor will be used to set the adjustment current of the voltage regulator. Let's take a look at how it works. The input voltage will be 230 volts AC, and we will use the transformer to step it down to 24 volt AC. A transformer has two windings. There's the primary winding and the secondary winding. This AC voltage will then go through our bridge rectifier. A bridge rectifier is a combination of 4 diodes. So if we have a look at how the voltage will look going through one diode, you'll notice that the diode will only allow power to flow only in one direction. So the wave will then look like this after going through one diode. Through the rectifier, this is the direction that the power will flow in. And once it gets through the rectifier, the first set of rectifiers will allow power in one direction. The other set will then allow the power in the other direction to flow. And the resulting wave will look something like this. But this is still fluctuating up and down, and we need it to be more at a stable level. So for this, we're going to use an electrolytic capacitor. Electrolytic capacitor will store electric charge, and it will act as a tank that will take some time to fill up, but also some time to dissipate this charge. So after going through the electrolytic capacitor, this is how the wave will look. It will stabilize more around a higher voltage point, and it won't fluctuate as much. And then this voltage will make it to the rectifier. When it gets to the rectifier, it will go on the input voltage side, and what we want to get will be on the output voltage side. A standard rectifier has an input voltage, an output voltage, and another lead for ground. For a variable rectifier, this is how it will look. We will have an input voltage, we will have our controlled output voltage, and we will have a reference current that is controlled by the variable resistor that you see at the bottom. Changing the resistance of the variable resistor will then control the reference current, and in turn give us a different output voltage. Let's have a look at how this power supply looks. So for this, I'm going to show a pre-built power supply. You can see here there are two transformers that step down the voltage from our AC input. Here you can see the other components, including the bridge rectifier as well as the electrolytic capacitors that are used. The variable resistor can be seen here on the side. We've also included a fuse for protection of the power supply. Now let's take some measurements. For the output on the far right, you can see that this is a fixed 5 volt. The output on the left side can be varied, and it goes all the way up to 16 volts. This adjustment is done by turning the variable resistor in one direction. If you turn it in the other direction, the voltage will then be lowered to a low point. Let's have a look at our results. From the video, we could also see the two different outputs of this power supply. On the far right side is the fixed 5 volt output, and that can be measured using the multimeter as shown on the screen. The output on the left can be varied from a 1.2 volt all the way up to 16 volt of DC output. Let's do some observations to conclude. A clearly defined process will help in the design of a circuit. The design process will create a process that takes an input and turns it into a desired function. A good understanding of component properties helps in making the best use of components in a design. Datasheets can be used for more complex components to understand their function and best design principles. There are many ways to make a power supply for your circuit. The safest power supply make use of low voltage battery power as an input. AC power supplies are more suitable for lab environment. Thank you, and see you in the rest of the videos.